Dr. Dipesh Kamdar is presently working as ad hoc associate professor in VC department, VVP Engineering College. I request everyone to please mute your mic, please. Please mute your mic. He has passed his graduation and post-graduation with distinction from Saurashtra and Gujarat University respectively, and he has done PhD in Electronics and Communication. He has 15 years of experience in academics working at various institutes like VVP Engineering College, Rajkot, and Engineering College, Visnagar. I request every participant to please mute your mic. Dr. Shilpa Shrigiri, please mute your mic. He has also worked as
Good afternoon to all. Welcome in the second session. As there were, microphone of few participants were on, so I have muted all. Prapti madam, you are requested to unmute yourself again and introduce Dr. Dipesh Kamdar sir, and then after sir will share the screen and start the session. Kamdar sir, now you will be able to share your screen and will be able to do the presentation. Prapti madam, am I audible?
Yes, I shared the screen. It's visible now.
Yes, sir.
Oh, I am audible.
Yes, sir. Audible.
Yes, good afternoon to everyone present here. Thank you, Vitsani sir, for hello. Am I audible to?
Yes, sir. You are clearly audible, and your screen is also visible to all of you. You can start. Yeah.
Thank you. So, good afternoon, everyone. Today we are going to learn something about IoT devices, sensors, and actuator. Myself, Dr. Dipesh Kamdar, working in Group Engineering College, Rajkot. See, what basically Thakur sir is already gives a brief about what is the current scenario going on. Means what is the development in the Internet of Things. So I'm not giving much on these particular slides. So basically, Internet of Things is nowadays machine-to-machine communications going to take place, and in future data science will be added together to make it more visible, more useful. This is the first stage IoT architecture. So basically, IoT architecture shows you that how your basically sensor devices can be connected with your IoT structures and what exactly actuator doing. Main thing here is how it differs from the embedded system. So basically, any kind of embedded systems which we are using is having some sensors. It has the onboard computers or any other computing boards available. Once your sensors data is fed to the device, computing device or controlling devices, then this device will definitely take the data from the sensors, do the process on the data, and actuating the actuators, which ended up with doing some actions. This is how your normal embedded device is working. But here in the IoT situations, what happens that your sensors data are fetched from the sensors. It remains same. Just your controlling device will be connected with the internet so that you can just access this data from the internet anywhere. You can reprogram your controlling device intermediately, and you can actuate the your kind of output device which is connected here. So the major actions between this is when it is IoT based systems, you can access the data, and intermediately you can change your programming, or you can make it activated your programs from the remote locations. While in the embedded systems, you need to reprogram it locally. While doing the reprogramming, you need to stuff the means while changing the stuffs, you need to maybe if in system application is not there, you need to disconnect the systems and then you can reprogram it. So IoT gives you the advantage of accessing it remotely. Along with this, you can just doing the intermediate programmings also. Now, basically, today's session, we are going to learn about the IoT structures and the sensors, actuators, and what are the IoT devices. So, I will like to start with a transducer. A transducer is a kind of device that converts any kind of energy into the another form of the energy. Special type of transducers which we can use to sense the physical or environmental quantity are known as the sensors. These sensors may be sensing the temperature, maybe the humidity, maybe the pressure, available in light intensities, plenty of things. So whatever the environmental data are there, you can sense physical quantities like weight, you can sense. Some of the special kind of transducers are known as actuator also. These actuators are basically kind of has responsible for moving or controlling your mechanism or systems which are there. Actuator basically needs some kind of control signals from your controlling device, and it need external energy sources for get it operated. uh, your controlling device is your brain of the system, which takes the data from sensors, uh, take some decisions based on the data, and activate or deactivated actuators as required or as programmed. So this is your IoT structure, basically sensor to architecture structure, where your sensor data is your sensor. Here in the examples, I am taking the temperature sensors, which detects the heat. It is given to your controlling centers. Controlling center will check the data. If heat is above the some threshold value, which is predefined by the programmer, then it activated the sprinkler, which is work as actuator here, and it will sprinkle out the water or liquid materials too, and takes the heat under control. So this is the scenario where uh, we need to our IoT is basically working. Now, what are the IoT sensors? So IoT sensors, as per the 2017's smarter world. 2017 when the smart world has identified the applications of IoT and find out the different sensors. They found that their sensor applications for the worldwide for different sensors are this much. So I'm starting with the temperature. So 11 percentage of the IoT applications are based on the temperature sensors, then force and load sensors by 6 percentage. Leak or level value sensor is only 2 percentage, electric sensor 4 percentage, magnetic sensors are 10 percentage. Likewise, the other sensors data are there. Then RFID sensor, ultrasonic radio sensor, acceleration or tilt angle sensors, vibration sensor, position proximity, chemical or gas sensor, acoustic wave sensor, flow meters, flow sensors, ambient light or machine vision optical sensors, humidity and moisture sensor. Uh, then the water level sensors, motion velocity displacement sensors. These are the sensors that sense this kind of quantities and give us the output. So basically, these sensors can be classified. Just give me a second. Okay, so these sensors can be classified based on the kind of use. It can be classified in different ways. So first is classification can be done based on the active and passive, whether the external power supply required to get it operated. If yes, then it is an active sensor. If it can generate without the external power supply, it can be called a passive sensor. Some of the active sensors are carbon microphone. You need to supply it externally, then it will work. Otherwise, you cannot just directly get the data from the microphones. These sensors are called parametric sensors. The passive sensors are sensors which does not require the external power supplies, like a thermocouple. It works on the basically the between the temperature difference between the two ends, and it generates some potential difference between the two terminals of the couplers, and you can just measure the difference, means potential difference, and you can get the output like a piezoelectric sensor. When it vibrates, then it generates the output voltage. You need to we can measure it, and once we measure it, we can just takes the data from that. That passive sensors are self-generating sensors which does not needs any external power supplies. Then there is some of the sensors which needs a contact. Some of the sensors are contactless sensors, so depends on that whether it requires to sense the physical data, whether we need a contact or contactless sensors are there. Then absolute sensors and relative sensors. Absolute sensors measures the absolute quantities, while relative sensors will sense the relative quantity, like if we can say that pressure. So we cannot have the value of the pressure absolutely. So normally what we are doing is we will measure the relative scale pressure, that on this end we are having this much pressure, and then with reference to that we can find out the different pressure. Classifications can be done based on the detection technology also. So electric sensor, then magnetic, electromagnetic, acoustic sensor, chemical or optical sensors are there. It can be also classified based on the physical laws like photoelectric laws or magnetic laws, thermal conductivity laws, like that. It can be classified into that. Classification can be done based on the specification also, like specification based like accuracy, sensitivity, stability, response time, hysteresis, frequency response. or can be classified as per the applications. That is, these are the sensors which are agriculture sensors, which are these are the sensors which is used in civil engineering, so or construction, so it can be classified in the civil applications. So these are the various ways, numerous ways to classify the sensors. Basically, as of now, what we can do is define the sensors, or we can classify the sensors based on the kind of output we are getting from the sensor. So, sensor can give us the output either in terms of the kind of electric signals, which may be the analog one or digital one. So based on that, we can classify it in the analog sensors or as a digital sensors. The role of sensor is to convert the physical quantity into the measurable low power electronic signals. Some sensors may not able to convert the quantity directly to the electronic signal. So we need multiple conversions before reaching to the measurable signals. When physical, the sensors outputs are analog one, then the analog data cannot be processed directly by our IoT devices. So what we need to do is we need to convert it into the digital data by using the analog to digital converter. Once we do that, it is may not be the directly gives us the output in terms of the sense information. Like if you are sensing the temperature, it is converted now into the analog signals by thermocouple or any thermal resistor based transducers. Then it gives me the some electric signal. Once electric signal is there, then electric signal is now given to the analog to digital converter. It gives me the digital output. Depends on the how many number of A to means how many number of bits A to D is having. It may gives me the output in terms of digital data, but this digital data directly does not represent the temperature. So we need to calibrate if the sensor is analog, so calibration need to be done. That if you get this digital amount, we are having 32 degrees Celsius. If we are getting this much amount, it related with a 34 degrees centigrade. So that calibration part need to be done. Analog sensors if it is linear, then calibration can be done easily. If the sensors are non-linear sensors, then you need to take care using the lookup reference tables so that you can just calibrate it accordingly. While on the other hand, we might have the digital sensors available, which itself generates digital data. Some of the digital sensors are just giving you the direct decisions that like PIR sensors, which sense the physical presence of any live animate in front of it. So if something is there, any human being or animal is there, it will gives me the yes logic one. Or if nothing is there, then it gives the zero. Some of these digital sensors can generate the bit stream. That bit stream can be transferred to the your controlling device, so that controlling device can fetch that bit stream and do the data processing and convert it back to the required data. Now let's start with a temperature sensors. There are plenty of different temperature sensors are there, but normally in the nearby environment sensing, we are using the LM35. It's a kind of analog sensor. It operating voltage range is 4 to 20 volts. It can work in the linear region between minus 55 degrees centigrade to plus 125 degrees centigrade. Its accuracy is 1 by 4 degree. Its sensitivity is 10 millivolt per degree centigrade. It has just three terminals. One is for supplying terminal number one. where you can apply 4 to 20 volt DC with respect to terminal number 3, which is ground. And on the terminal number 2, it will generate the output voltage, which is directly proportional to the temperature it sends. So from the pin number 2, we can get the converted analog data here. We need to convert it with the digital data using analog to digital converter. Once you have the digital data, we need to convert and calibrate to the temperature degree. Now see, for example, if we are using the 10-bit ADC, and we already know that what is the sensitivity of that sensor is 10 millivolts per degree centigrade. So once you are having the A to D converted data, then the voltage measured can be ADC reading, means your analog to digital data reading, multiplied with whatever the DC voltage you are applying on the terminal number 1, divided by 2 raised to 10, because it's a 10-bit ADC. If you are having a 8-bit ADC, you need to change it to 2 raised to 8. If 16-bit, then 2 raised to 16, depends on the kind of ADC you are using. And degrees, for degree Celsius temperature, ADC reading multiplied by VDC into 100 divided by 2 raised to 10, so that you can just convert it. It's a basically linear sensor, and it gives 20 millivolts per degree centigrade. So it's directly gives me the output in a calibrated form, where I can just calculate the temperature directly. Otherwise, whatever the relation, that relation we can find out from the data sheets of the sensors, and then according to that we need to do the process here, and we need to convert or calibrate. Uh, on the other hand, if I say that I have the digital temperature sensor, which sends directly means temperature and gives me the readings. So digital sensors like DS18B20 is a temperature sensor module directly available. It gives me the digital output on the terminal. So it's basically predefined one wire protocol using on the baud rate of 9600. I can just fetch the information from the sensor module, and I can find out that what is the temperature there. So basically digital sensors does not require to calibrate. We just need to fetch the data and convert the data to by looking the lookup reference table, and convert the digital data to measured quantity. Same way, we can have the proximity sensors. Proximity sensors are the sensors which can sense the presence of the object. So this is the proximity sensors. It has the infrared light. It transmits the infrared light in terms of pulses. Once a pulse emit from the LED, infrared light can then goes in the line of sight of communication. Then from the object, it reflects back. So once it is reflected back, your IR receiver will sense that what is the intensity of the light received, how much time it is consumed to travel, go, and coming back. So based on that, we can just find out that where is the my object is located. Normally, this proximity sensors can be used for 10 centimeter to 80 centimeters far away, means identify the distance from 10 centimeter to 80 centimeter. As the object is nearby, the generated voltage on the output terminal will be high. If object is far away, then it might be a zero or very low value. So once we are having this, we can say that the sensor data will be zero if there is a no reflected signal from the up to 80 90 centimeters, and if the object as close as 10 centimeter, we will get the linear output voltage 5 volts. Now we know that from 10 centimeters we get 5 volt from the 80 centimeters we will get 0 volt. So now we know the range of voltage which we are going to receive. We already know that what is the range. So if I am getting the 2.5 volt, I can say that my object is approximately 40 centimeters away from the sensor. So this is how you can we can calibrate the sensors data and find out the distance using proximity sensor. Same way, there is an ultrasonic sensor, so having a which is also used for finding out the distance from 2 centimeter to 400 centimeter. But the working principle is getting changed. Uh, your proximity sensors transmit the infrared pulses, while here we will transmit the acoustic pulses. The acoustic pulses are transmitted and the reflected waves will received. Once you receive the reflected wave again, echo pin, it has the 4 pins: VCC, ground, transmission enable, and the echo pin. So once you uh, activate it when the 10 microseconds or for more time, it will trigger the pin and 8 pulses of 40 kilohertz are generated. So it's basically 40 kilohertz signals will be transmitted. It is non in the non-audible range, so it will not disturb the environment. The echo pin is made high by the control circuits in the module. Now, echo pin remains high till it gets the echo signal back. So once you get the back signals, then we can just compute the time required to receive the signal. The received signal, you can just compute the time from the echo pin, that what is the time difference between the transmitted and the received. We know that what is the velocity of sound wave to travel. So from that we can just find out the distance using the simple calculation. Then we are having the load cell sensor. See, weight sensor basically. There are different weight sensor available based on the what are the load you want to measure, what is the range of the load you want to measure. The load sensor are available in the field. You need to choose the depending on the weights and accuracy you required. Load cell cannot be directly interfaced with the controller because it gives the change in the voltage, change in the resistance in the load cell. So basically, it has a 4 wire connections. When the weight applied on the load cell, the load cell will bend a little bit, and depends on bending. Resistance is changing because we know that R equals to L rho by A. So depends on the change in the length a little bit. Small variations is generated. That variations is that much small that we cannot directly connect with device and we can measure. So we need kind of interfacing circuit along with the load cell. So here is the one of the directly load cell amplifier is available. HX 711 is load cell amplifier which we need to connect. It has the precision 24-bit analog to digital converter. So we can get the digital data from this weight sensor. So basically, 4 terminals you can connect here: EE minus A and A plus, or you can connect it EE minus and BB plus. Depends on the kind of sensors you are using, kind of application, what is the weight requirements, what is the accuracy requirement. Based on that, we need to choose between A and B terminals. Then internally it get amplified and they converted to 24-bit digital data, which it transmit to through the DT and SC cables, so that once you send the serial clock in, it will transmit the digital data back to us, means back to controller, and we can just find out that what how much amount of weight is placed on the your weight sensor. Similarly, we can have the water level sensor. So in the water level sensor, these are the strip lines where sensor trashes and power lines are there. So when water is on the line, it will becomes a conducting between the two lines. So power lines, power connected with the sensor lines, and we can sense that how much connectivity is there. Normally, this sensor, though it is a water level sensor, once you put into the water, if the water is connected up to the some specific level, it has the low resistivity because the connecting path is on the higher side. If it is on the lower side, it will have the higher resistivity, so that basically it converts the uh, change of resistor into and we can find out what is the level. Normally, this sensor is not used for water level identification nowadays. For water level, we are using the different sensors, but for the raindrop sensors, we are using these water level sensors more effectively. And then the soil moisture sensor. If you go with a soil moisture sensors, we are having lots of soil moisture sensors available in the market. The most popular is shown in the figure where these are the two strips which is placed inside this your soil. Uh, on the left hand side diagram shows the working principle of the soil moisture. So whenever we are having a VCC connected with the one strip and the another strip is connected with the amplifier, if soil is dry, there will be no chance of conducting from the VCC towards the another strips, and there will be a no conducting material available in between, so there will be a no current flowing that. If soil is having some moisture, then this moisture can able to conduct the it will work as a conducting material, and some of the amount of electrons which is available from the VCC will able to reach to the another terminal, and that is a very low amount of current, so we will use the amplifier here, so it will gives me the amplified signal from the amount of uh, current that is able to pass through this. We can have the data here, and this data again we need to calibrate that this is the amount of moistures we are having. Normally this once you find out the what are the amount of moistures you are having and then set up the threshold according to that, then controlling actions can be takes place. Similarly, we can have the light sensor also. The light sensors we can use the LDR. LDR is basically works on the photoconductive principle. So when the light's forces on the surface of the photoconductive material, it will have the some of the electrons which is already there in the valence band. It will jump up to the conduction band, and the due to the free electrons now jump to the conduction band, we can have the more conductivity if the light is there. If light is absent, it will not get the photon energy from the lights, so it will be back to the valence band, and then resistance is high. So if light is falling onto the LDR, its resistance will reduce. The amount of light falling depends on that, the resistance will reduce. Uh, so from that change in the resistance, we need to measure that. what is the amount of light is falling on the surface, and based on that we can just find out the how much amount of light intensity is there. It's basically kind of a non-linear sensor, so basically it's very difficult to calibrate once we are using. So sometimes when intensity is not the intention, but if you see that outdoor light control, okay, so if intensity is followed by some specific level, then we just need to turn on the external means natural light is gone, then we need to turn on the outdoor lights. So in that scenario, this sensor is useful because of its economical price. Otherwise, for sensing, finding out the light intensity, use of the LDR is very difficult. Again, its surface is having a smaller cross section area, so it gets the affected with environmental issues like a dust, or if it comes in the shadow, it suddenly light intensity fall down. So not used for the specific purpose of the finding out the intensity of light, but very useful for taking the decisions whether the light intensity is good enough or not. So in order to find out the what is the intensity of light present here, so that can be sensed by the ambient light sensor. There are again plenty of ambient light sensors are present in the market. One of this well-known and more useful nowadays is BH1750 digital light sensor. The output is directly calibrated, and it will give the light intensity which is measured in the lux, so does not require any further calculations. This works on the sorry. The sensor basically works on the I2C protocol. So when you we will have the two pin connected serial clock and serial data. So with this serial clock and serial data, we can fetch the data from this. Then the flow meter. See, flow sensors that how much amount of liquid flow is there. So we need to, if we need to find out the flow, so basically works on the principle of the Hall effect. Now, what is Hall effect here? The Hall effect is generating a voltage across a conductor when current is flowing through it, and the same instant it is exposed to a magnetic field. The voltage difference can be measured and calibrated across the scale. The voltage difference depends on the properties of the conducting materials, means which metal we are using for conducting that. In case of flow meters, the passing liquid or gas volume can be calculated by taking into the account constraints such as area, pipe size, nozzle, velocity, speed, or whether it is gas or liquid passing through the valve. Hall effect sensor is composed of a two part. One is stationary part, which is the Hall effect sensor. It is, and the another part is magnet. The magnet is attached to the surface which is movable, and the Hall effect sensor is placed perpendicular to the magnetic field of the magnet to find out. So this is the basically normal structure for the flow meter. So when air or fluid is passing through this rotor will be getting rotated. Once it is get rotated, we can just find out the means it once it is get rotated, it will be the magnetic field will be varying. Based on the magnetic field varying, voltage is generated, and this voltage is calibrated. So this voltage is once find out, we can just put some complex calculations for the finding out the how much amount of flow is there. Then the smoke or gas sensor. The MQ2 is a smoke sensor which is sensitive to the smoke and flammable gases like LPG, butane, propane, methane, alcohol, hydrogens. The resistance of the sensor is different depending on the type of the gas. So again, if we use the sensor, its resistance the change depends on the kind of gas. So smoke sensor has a built-in potentiometer that allows you to adjust the sensor sensitivity according to the how you want to detect the gas. If you just want to detect this gas, or you want to find out that which gas is there, you can find out. But this is MQ2 is not the only the smoke sensors. We are having a list of the gas sensors available, which is used for some specific kind of gas. Like MQ8 is used for hydrogen, coal, gas. MQ9B is a carbon monoxide sensor. MQ2 is used for flammable gases or smokes. MQ5 liquid petroleum gas, methane, coal gas. MQ135 is for ammonia or sulfide type of gas. MQ3B is for alcohol detection. MQ7B is used for carbon monoxide. MQ4 for a natural gas or methane. MQ2 flammable gases or smoke sensor. MQ6 for liquefied petroleum gas, isobutane or propane. MQ5 is for liquefied petroleum gas, methane, coal gas, and MQ7 for carbon monoxide. So these are the different gas sensors. Based on the application, we need to select the sensors that what is we want to find out, and basically what is the basically use of the means gas sensor in the system. So if you just want to detect whether the gas is present or the amount of gas is present, depends on that, we can have this all the gas sensors which is available easily, and we can use it. Then the vibration sensor. The vibration sensor, like we are having the module SW420, which is a vibration sensor. It has the comparator like LM393 is used to detect the vibration. So this is the vibration sensor. When it vibrates, it can just generate the vibration, and we can find out that how much amount of vibration is there. We can change the means it just gives us the digital output that vibration is there or not, so we can have the port adjustment here. So it's just this is kind of sensor which gives the digital output like 1 or 0, so vibration is there or not, it just detects that. So on how much amount of vibrations we want to take the decision, that needs based on the decision which LM393 comparator takes place. So on the another side of this, there is a potentiometer to set the amount of vibration which we want to set as the threshold, and here it will sense the vibration. So if vibration goes above the threshold value, which is set with this 10K potentiometer, then it gives me the output as a logic high. If there is a no vibration or vibration below the required threshold level, then it will gives me the just output low, because the vibrations are less. Then the gyro sensors are working based on means work on the principal base of the Coriolis acceleration. See, in the right hand side image, you can see that there are three axes x, y, and z are given. Now, imagine that there is a fork like a structure that is constructed back and forth motion. So once you move it, it will have the piezoelectric crystal inside that, and it will generate the piezoelectric effect there once it rotates or vibrates. So once it get rotated, we will have the xyz coordinated output available. From that we can find out what is the amount of movement is done, and means x, y, and z direction, which direction tilting takes place or movement is done. Gyro sensor will have the, again it works on the I2C protocol, so it has the serial clock and serial data available. We can just fetch it using the I2C protocol from this. MPU 6050 sensor module is an integrated 6-axial motion tracking device. Though it is basically 3 axis, but left and right consideration make it 6-axial motion tracking device. It has a 3 gyroscope, 3 axial, 3 accelerometer, digital motion processor, and the temperature sensors also inbuilt in a single chip. So this can give a temperature also. It can access the input from the other sensors like a 3-axis magnetometer or a pressure sensor using it auxiliary I2C bus. It has the 3-axis magnetometer is connected. It provides the complete 9-axis motion fusion output. A microcontroller can communicate with this sensor using I2C communication protocol. Various parameters can be find out by reading the values from the address of certain registers using the I2C communication protocol. Gyro sensor and accelerometer readings along with the XYZ axis are available in the two's complement form. So when you are trying to read it, we need to convert back into the original data because it's available in the two's complement form. There are another sensors like motion sensors, capacitive touch sensors. When you touch it, it will just change its capacitance. Motion sensors find out whether the something is some live element is present in front of it or not. Um, then the flex sensor, joystick sensor, uh, and then RS-232 camera sensor, fingerprint sensors, GPS navigator sensor. These are the all the sensors which you may use for the sensing the different things from this real world and feed it to your controller. Now, if I can just conclude, there might be thousands of sensors still left to include here with the due time with the given time. So I'm just not able to include all the sensors which are available. So basically what sensors do for us is sensors need to interface with the IoT device, and your sensors can be of analog sensor. Once we are having the analog sensors, what we need to do is we need to get the data from the sensor, convert it to the digital data and calibrate it. There are some digital sensors available which just gives us the direct output in forms of yes or no. It just have the intermediate threshold level. You can maybe some of the sensors having you can set it or vary it like that presence in the vibrator sensor, so that if a vibration is above some threshold or below some threshold value, then it gives me the digital output whether it is yes or no. Like a proximity sensor. So once proximity sensors detects any live animate's presence in front of it, it gives me the output yes, something present, or it directly gives me the outputs that nothing is present. There is some devices like a one wire sensor, like LM35 sensor, which is a one wire sensor which gives me the output quantity which I need to get it with the one wire protocol. Some sensors are based on the serial protocol, like mostly it is used the SPI or I2C bus protocol. So whatever the measured quantity is there, it converts and it can transmit to the your controlling device with the SPI or I2C buses. Some of the sensors are able to sense, convert, and transmit the data with the Bluetooth, Zigbee, near field communications, or RFID. So basically, these sensors once sense the information, means physical quantity, takes the input, and it needs to be given to the your controlling device. Then controlling device will convert into the required field, calibrate it into the its equivalent value, and then a process can be takes place. So this is about the sensors. If you have any queries in the sensors, you can ask here. Let's let's wait for the question answer sensor, and at that time you can ask the questions on the sensor.
Thank you very much, Dr. Dipesh Kamdar, sir.
Uh,
I think you have given a very, very good idea, basic principles of all the sensors. I think still some part is there, no? Actuators and all that, right?
yes, actuator
Okay.
and the
Okay.
controller
Okay.
part is still left.
Okay. Fine. Then after we will conduct the question answer session, right? There are a few questions are there in chat section, but I think we will get we will
Okay, I
discuss
will
question answer
in
session,
the
right?
right after the
Okay.
session.
Okay.
Okay, so basically actuator. So I will just go back to the basic that. See, the actuator is again a kind of transducer which whatever the sensing quantity we have taken, from that we need to take some decisions. Once we take some decisions, then the actuator need to act something. Uh, like if we have the automatic door system. Okay, so what we are doing is we will put the sensor for distance measurement, either proximity or ultrasonic sensor we will put and find out something is there in front of it or not. Once somebody comes in the front of the door, we sense that using the sensors that something is present, then we need to open the door. How we need to open the door? So in order to open the door, we need depends on the kind of door we are having. We may have the DC motor or AC servo motor or DC servo motor or stepper motor there. We need to activate it. Once we activate it, it will open the door. So actuator is again a kind of device which accepts the some of the control signals from our IoT devices, and then it will act accordingly. What is the control signals are given, and it will actuated, and there's some physical movements may be done, or some actions is taken place, or some device may be turned on or turned off, depends on that. So normally first actuator device which we are using is a buzzer. So it works on the basically principle of the piezo transducer. It works on the DC. So once we can just need to supply it with the 5 volts and it will generate the sound. It can be used for the some actions takes place or indicating the people that something happens if you are having a gas sensor connected with your controlling device, and if you it finds that there is a gas, so you can just alert the peoples by actuating the buzzer. So buzzer will generate the beeping sounds, and the peoples who are in nearby field will able to listen that, and we can have the alert system. So it's basically working principle is as simple as LED. You can just give the supply, it will start beeping. Then the another actuator is relay. Most of the time, when it comes to IoT field, whatever the our actuators are there, it's working on the AC. While our controller based systems and our controlling device are working on the DC. So intermediately, when we need to connect this AC and DC supply, intermediate to that we will have the relay. What relay is a just kind of replacement to the switches. So we can just eliminate the switch which we manually turn on or turn off. It now can be activated or deactivated with the help of the control signals. So its basic working principle is electromagnetic attraction. When the on the right hand side diagram you can see that there is a one coil mounted on the red bar, iron core bar. So when a current is passing through this, it will get energized and it will generate the magnetic field. This magnetic field will attract the switch and it will turn on. Once no current is passing through the field, it will again going back with the internal connection of the spring action. So spring it pull it off and the connection is lost. So basically it is turn on and turn off by the passing the current through this relay. Uh, So there are four kind of relay switches are available. One is single pole, single throw, single pole, double throw, DPST and DPDT switches are there. The single pole, single throw switch is just a turn off mechanism, while SPDT can be used where the two connections are there, A and B. So you can just, for example, if we want to maintain the temperature here, so we can have the one side fan or cooling system is there. On the other side, we are having a heater is there. So once we can connect the our input line to C and the fan to A and heater to B. So once temperature increase, we can turn on the fan. If temperature decrease, we can turn on the heater. So for this kind of applications, we can have the single pole double throw. If we don't have the another side system, then also we can use the SPDT. Means if temperature goes high, we need to turn on the cooling system. If temperature remains low, we want to do nothing, then keep the terminal A open and you can use the terminal B with your cooling system. If we have the high power connections, then we can go for double pole single throw systems where multiple devices can be operated along with. Depends on applications, we can select this relay board, means relay which can be replacement to your switches. Now this relay basically it can be used for DC as well as AC on the secondary side. If you are using for the AC, ensures that you are not using in the hazardous environment. Because what happens is that when the switching actions takes place, at that time a minor spark actions will take place. So in the oil and gas environments we cannot use this kind of relay which is electromagnetic. So there are another types of relays are there which is called a static relay. We can use this static relay for the same, which does not have any mechanical movements over there. It was just using the track for controlling the AC power going through that. So we can use it in the hazardous environments, static relay, where electromagnetic relay cannot be used. Some overcurrent relays are also present which deactivate the circuit if current is excessive above the some specific value. So in case of short circuit or a high amount of current fetched by the or any of the device, you can just turn it off. Or thermal relay which works on the basic principle of thermal conductivity. So once thermal means you can use it on both the side. On the if temperature goes high, it will start working, or if temperature goes below something, it should start working. Depends on the how you are connecting your relay. We can have this relay working. So relay is basically once you are using this, it will just work as the isolator between the your circuits. Sometimes we need to take care of the while using the relay, we need to take care because it working means combining the AC and DC power. So once if you are not aware much about the relay, so just go through the detail first before selecting the kind of relay, and that selection should be depends on the where you are using. If you are going to put some devices in the hazardous environment or in the kitchen, I recommend that don't use electromagnetic relay anytime. Then the DC motor. Now DC motor is having a simple phenomena like if you give the supply, it will rotate. Now rotation can be converted into the linear motions by connecting the some specific hardware. Uh, but when we need to connect it with our controlling device, some little bit of interfacing need to be done. So this is the basic interfacing where you can just need to rotate in the one direction. So you can just give the here a pulse. This BC547 transistor is used. So on the given pulse, if you give a logic 1 here through the 1K resistor, it will turn on. It will provide the path. So VCC is now connected with the ground through BC547, which is turned on by providing the logic high here on the base terminal. So motor will start rotating. If you give a 0 here, BC547 is turned off, and with this turn off condition, though motor will get the VCC, but it does not get the ground. So circuit is black and there will be no current flowing through motor. So there will be no rotation in the motor also. When motor is basically DC motor can be used as a generator also. So some back EMF is generated, and for that back EMF we are putting the freewheeling diode across the motor. So this is in 4148 can be placed, or in 1 and 4007 can be also placed here. Now see if you are having a high power motor like it consumes the 24 volt DC and 500 600 milliampere of current, and you can just put the Darlington pair based on transistor TIP122, so that amount of current can be handled. So depends on the kind of motor you are using, interfacing circuit may be changed, or we can have the motor driver circuit. When connecting the DC motor to IoT devices, it may permanently damage the output pin of your IoT device due to the back EMF generator and then back EMF passing. So it is better to go connect the DC motor with a driver circuit, or we can go for optocoupler isolator so that it is save our IoT device. So this is the optocoupler IC, that is 4N35, which can be used. See, this is the isolation. So whatever the back EMF generated may not travel back due to the opto isolations, where optical transmission is done from the LED, and this transistor is get activated on receiving of the optical source. Though something happens wrong here on the secondary side, means motor side, this device means your opto transmitter transistor will not able to reach to this optical LED source, and hence your whatever the your IoT device connected here will not get back EMF generated, or any short circuit actions takes place on the secondary side will not affect your uh, controlling devices. Then the stepper motor. Basically, DC motor can rotate, but the number of rotation it takes place is not 100% controllable. If you see that once it is in the motion, okay, so once you stop it, the means you try to stop the DC motor due to the frictions and the motions available, it will rotate a little bit further, so it will not stuck at specific time. Again, load bearing capacity of your step DC motor is very limited, though it can use for heavy loads, so you can use the heavy motors, but still its number of rotations it takes place is not 100% controllable. So instead of using this, when you want to control the number of rotations takes place, stepper motor is a better option. It works on the based on the step size. Once we are having the fixed number of, means we know that how what is the stepper motor and connected the wheels or any other devices with that, the number of steps it rotates and the number of distance it covers, we can just compute it with the radius of the size of the wheel or the any other devices it is connected. So it just gives you the perfect number of steps. You can just compute the perfect number of step size, and it will work perfectly, or distance covered perfectly by the robot if you made. If you want to lift the any, it basically it has the it works on the basically electromagnetic field generation, so it has the electromagnetic locking inside. So once the electromagnetic field rotates, along with that only it can rotate, otherwise it just stuck with the electromagnetic field. So once it is locked, its position cannot be changed itself, or it cannot rotate it externally. So when your load is heavy, we can use the stepper motor. Basically, stepper motor is having the either 4 terminals or 5 terminals or 6 terminals. These are the two windings here. Once a magnetic field is generated by this winding and this winding, it generates some fixed magnetic field. According to that, motor is locked. Now we can just turn on and turn off the winding energy. So by turning on and turning off this winding energy, we can have the magnetic field which is generated is rotating. Along with this rotation, stepper motor will rotate. So four connecting terminals need to be connected with your controlling device using this LN2 ULN2004A. This is one of the interfacing IC. You can use plenty of different ICs available for the interfacing. Depends on your application, size of stepper motor, the current need to be handled, and the load bearing which need to be handled. We can select this different IC. It will just ensures that the power required by the stepper. Sorry, give me a second. Um, sorry. So your basically controller can whatever the IoT device is there, it can gives you 0 to 3.5 or 5 volt, while your stepper motor may need a 12 volt or 24 volt supply. So this driver circuit will help you to boosting the current, and it will again works as the isolator as and when needed. Then it goes to servo motor. Servo motor is basically working on the uh, uh, for the specific position. It just rotates 0 to 180 degree. Depends on the what is the pulse width of your output pulse. Basically, if with the minimum pulse width of 1 millisecond, it rotates 0 degree. With the maximum pulse width of 2 millisecond, it rotates the 180 degree here. If you gives the pulse width of 1.5 millisecond, it will rotate the 90 degree. So now we can decide that at which degree we want to rotate. According to that, we need to use the pulse width differently. You can control this pulse width by switch turning on and off your output pins of your controlling device, and we can just control the angle of the servo motor. So servo motors get usually basically gives you the just a conversion from 0 degree to 180 degree. So it gives you to select the sometimes directions also. There may be the many other actuating device you can use along with this, but due to the time constraint, I have not added all the devices here. I just keep it to which is mostly used for the actuator here. Then it comes to IoT devices. The role of IoT device is to collect the some data from the sensor, and they send actuating signal to the actuators. So your IoT device need to able to receive the data from the sensor and send the control signals to the actuator. If your IoT means your controlling device is not connected with the internet and it takes the local decisions, then you can say that it is a kind of embedded system. And if you are connecting your devices with the internet, then you can say that it's a kind of IoT based system. Sometimes people get confused between NOT and IoT, so I just would like to clarify that. The network of things is the kind of device where you can just connect it when you comes in the field of this network. Like you are having infrared remote. So infrared can work within the given range of say 60-70 meters only. So if your comes in that range, then you can activate like Bluetooth, personal area communication. So it will work only if you are in the range. So if you are connecting like this, you can say that you are on the network of things, not the Internet of Things. Internet of Things is that once you are there, anywhere in the world, and through the internet, if you can send your controlling signals to your controller, then it get actuated, then only it is Internet of Things. Otherwise, if you are in your personal networks, then it will be considered as a network of things, not Internet of Things. There are plenty of microcontrollers, I can say that which is available nowadays with the facility of which for the connecting the Wi-Fi or through Ethernet, which out of which we are mostly going to get the during this FDP, we are going to use the two of the microcontrollers. So one of the Node MCU. Node MCU is a low-cost open-source IoT platform designed. It is designed with the ASP8266. It has the onboard Wi-Fi chip, so it can connect with your Wi-Fi, and by accessing your Wi-Fi, it can just connect to the internet. And once it is connected, you can operate it from anywhere. Plenty of GPIO pins are available for your interfacing. It supports the different protocols also on board, which is there. And the another IoT device which we are going to use during this FDP is Raspberry Pi. Raspberry Pi is a kind of single board computer developed by Raspberry Pi Foundations UK. It has the Ethernet ports, USB port, and audio jack connections, USB connections are there, along with plenty of GPIO pins available. So from the general purpose input output pins, we can connect with the device we want to the sensors from which we want to data. We are going to learn about all the protocols and these two boards deeply, like in the later on session. So I have not included plenty of things about these two boards here. So now any questions if you are having, you can ask. So
thank you very much, Professor Dipesh Kamdar sir. These sensors are, it's very important for IoT applications, because basically it will collect the real world data, and all the edge devices like Raspberry Pi and Node MCU will communicate this data to cloud after necessary processing. There are a few questions are there in the chat box, sir.
I'm just starting with.
One question is that which sensor we can use for NPK mineral in soil?
Sorry?
NPK mineral in soil. So it's, I think, for some kind of in a fertilizer. Let's say there are some different types of phosphorus and nitrogen and all that. I think Mr. Ankit Agrawal has asked this question in the chat box. It is there.
I'm just facing some network issue here in the team, so just give me a second. I'll just find out the question and answer it. I think it's he's asking about the NPK.
NPK minerals there. I think some optical sensors must be there, because nitrogen, phosphorus, and potassium, these are the minerals normally available in the soil, and then for that actually optical sensing must be useful, I think.
Right, optical sensings can be used, and the presence of
I think NPK means nitrogen, phosphorus, and potassium. I think, if I am not wrong, Ankit, you are asking about that nitrogen. You can unmute your mic and also discuss with us. No problem.
Yes, sir. Absolutely.
Nitrogen, phosphorus, and potassium.
Yes,
you
sir.
want, okay. I think some optical sensors must be there. I don't have actually much idea. Kamdar sir, can you do you have some idea about it?
No, sir. Actually, NPK sensors I have not used so far. That might be more familiar in the somebody is doing the research on the agriculture side or the something specifically soil sensor. But
I could find one research paper based on this. Just now I was searching for it. So I think I will upload that research paper in our file section so that later on you can refer that paper, right?
Definitely. Ankit bhai can refer it. Now I think my system is turned on. So.
All right, you are charging issue, right? Okay. How many sensors are available? Mobile phone, we have already given the answer. I know our colleague Asutosh Bhatt, he is also participant in this team. He has also answered it in that way.
And mobile phone, there are.
I think heartbeat sensor, somebody is asking, try to cover heartbeat sensor.
Yeah, there are, see, hardware nowadays, plenty of wearable sensors are also there, so we can just wear it and we can have this data from the wearable sensors also. Heartbeat sensors can be working on the pulse measurement. There are two types of heartbeat sensors are available, which I have used. One of this with the optical sensor, so it can just find out the how many pulses are there. Means passing the intensity through your fingers or earbud, so that it can just find out the rate of blood passing through it. So passing of this blood will just cut the intensity of light. So from that changing of the light intensity, we can just measure that how many number of pulse per minute is passing, and we can just find out the heartbeats. I will definitely share the details of the heartbeat sensor separately here in with this sir. So sir will put up along with this material, so you can just access it about the heartbeat sensors. Yes, anything else, sir?
Participants, you have any questions? Meanwhile, Prapti madam, you want to share something?
Important okay, these are the instructions.
Instructions for participants actually, yeah.
Okay, sir is saying that heartbeat sensors will be covered in hands-on sessions. Yes, any participants have any questions you can ask?
Ankit Agrawal, I have just recently shared one paper related to your question in WhatsApp group. So I think it's only for you. Others may not be interested in that. So I already shared in the WhatsApp group. Meanwhile, we will be conducting one pre-test today, and that link will be available to you under the assignment section. So just you have to click on that, and there are 10 questions are there, multiple choice questions are there. This test is compulsory for all of you. Of course, whatever the marks you obtain, whether 0 or 10 out of 10, it doesn't matter, but just you have to appear for that test. So this is one kind of a mock test. So similar test we will conduct on the last day of FDP. And on the last day of FDP, whatever the test we will conduct, in that you have to secure 60% of marks. But for today's test, whatever the marks you get, it doesn't matter, right? But just you have to appear for that test. Test is compulsory for all. The link will be available under the assignment section. And some of you are having a still doubt that how to get this material, learning resources. So again, I will share the team with you, and I will show you where the materials will be available exactly. Okay, one more thing I want to share with you is that many friends actually are actually clicking on this completely a wrong session. Just now the session 3 was going on. Few participants were there on session 1 and 2. So please click on the corresponding session only. Otherwise, what we will do, we will delete all other sessions and we will only keep one current going session. Actually, we have placed entire timetable here. So you just click on the corresponding section. Do not join other sessions. Otherwise, your attendance will not be counted. Regarding these files, actually it is there in the Teams. So just click on the Teams. You will find the team ATAL FDP on Internet of Things, and here you will find the general channel, post and files. So under the files section, you will find all the materials here. And in assignment section, link will be available. But that link will be available to you at 5 o'clock only. Before that, it will not be available in your menu because it is scheduled test. So it will available at 5 p.m. If participants have any doubt regarding the utilization of Microsoft Teams, please ask so that I can clarify it.